the chain rule. Now the chain rule can be used to differentiate a function when it's really a composite function. One function composed within the other function, so that you have what is called an inside function and an outside function. And it's useful when it's difficult to separate those functions, right? The general way that is written, if you, for example, you have y is equal to f g of x, right? And you say, suppose you let g of x be equal to u, so that y is equal to f of u. Then what you have is that dy by dx is equal to dy by du multiplied by du by dx. So you notice that you will cancel u here, so what you really end up with is dy by dx, right? So you call this function now the inside function, and f of that is the outside function. So you name this u, and then you say this is f of all of this, which is u. So this would be u, and you find f of this. So you use this method. So it's dy by dx is equal to dy by du times du by dx. Let's look at an example. Let me erase these. We'll look at an example here. Now suppose you have y is equal to, what would it be now? X squared plus 3, and that is squared. Alright? Let's not use a chain rule at first. Let's use expansion and work it out and see what will happen. Then we will use a chain rule and see if we get the same thing. So now, x squared plus 3, or squared mean x squared plus 3 times x squared plus 3. So this is y equals this. What would this be now? X squared by x squared gives you x to the 4th, plus x squared by 3 is plus 3x squared, plus 3 times x squared gives you 3x squared, plus 3 times 3 gives you 9. So what you have is x to the 4th plus 3x squared plus 3x squared gives you 6x squared plus 9. Now, let's find dy by dx. Remember, this is y. So dy by dx would be, and using the power rule, multiply by the whole power, which is multiply by the power of x, which is 4, x to the, and then you reduce the whole power by 1 to get the u power. Same thing you do with this. This is 6x squared, so it's 6 times 2 x to the 2 minus 1 plus, this is really 9x to the 0, right? So it is 0 times 9x to the 0 minus 1, and then you have 4x to the 3 plus 6 2's 12 x to the 1, which is just x plus 0. Don't bother to write that. Alright, so here we have it. So what we're saying here is that dy by dx is equal to 4x cubed plus 12x. So that's what we get for that. Let's use the chain rule now. Let's erase all of this thing here and use a chain rule on it. See if we get the same thing. Alright, now we have something that is squared. So this function is in the form of another function squared, which is the inside function squared. So the inside function is x squared plus 3. So let us say that u is equal to x squared plus 3. And then we are saying that y is equal to x squared plus 3 squared, right? What we have is x squared plus 3 squared. But then a while ago we said u is equal to x squared plus 3. So let us just call it u squared then. So it is u squared. So y is equal to u squared, but u is x squared plus 3. Now, what we say here is that dy by dx is equal to dy by du times du by dx. I put the dot here. Sometimes that's used as multiplied by. So sometimes instead of the multiplication sign, the dot is used. So now, this is dy by du. When you look at this, using the power rule, dy by du would be equal to is 2u. Alright? Using the power rule, that's 2u. And what is du by dx? Du by dx is equal to multiply by 2, x to the 2 minus 1, it is just x plus 3. Alright, so this is what we have. So we have dy by du and du by dx. So we can write here that this is dy by du, which is 2u times du by dx. But du by dx is 2x. It's 2x. The thing is now, what was u? U was x squared plus 3. So we say this is 2 times x squared plus 3. Then plus 2x. Alright? Now, here, no, multiplied by 2x, not plus 2x. It's multiplied by 2x. This is a multiplication sign. So it's multiplied by 2x. So how do we work this out now? What does this give us? If we say 2 times, put the 2x in front, times 2x times x squared plus 3. And then 2 2's 4x times x squared plus 3. So what we have here is 4x times x squared give you 4x cubed plus 4x times 3 give you 12x. Alright, we have 4x cubed plus 12x. Oh, 4x cubed plus 12x. So it does work out in this example. Alright, so in this case, what we did first was to expand this and differentiate it. Then we use the chain rule, recognizing x squared plus 3 as the inside function, saying that u is x squared plus 3, then y is equal to u, this, u squared. Then use the chain rule, and we got the same thing. Alright, we continue looking at the chain rule next time, so I will see you.